ठीक है, we will start.
Sir, recording.
शुरू है recording.
अरे आपने को डका चेक करो पक्का आराम लादे क्योंकि अदर जनरेशन को इन दो आराम लादे.
It is getting recorded.
Very good, sir.
ठीक है. So we have discussed related to the design of lacing flat. We have identified the dimensions of the lacing flat, in which we have selected 50 mm wide plate, and that 50 mm was calculated based on the IS 800 clause, if you remember. Okay? From this, for single lacing system, we are supposed to consider the width to be 3 times phi. Phi is the diameter of the bolt. So initially you are supposed to consider the diameter of the bolt which you are supposed to connect, right? And you can consider 16 mm to be the starting diameter of the bolt. So you can see with the calculations we have found that the lacing flat, whatever we have considered, that was okay, that was safe. We are supposed to check the capacity of that lacing flat for compression as well as for tension. That's what we have done. So we have found out, in order to calculate the compression capacity, we are supposed to calculate the effective length. That effective length is necessary to calculate the slenderness ratio, isn't it? Once we get the slenderness ratio, then we can evaluate this PD value, design load. Then, as I have told you, that this complete system will experience an accordion kind of action, wherein you will experience that one lacing flat will have compression and at the same time another will have tension. So some or the other member will have compression or tension. There may be a possibility that a member which is carrying a compression force may experience tension at the next loading step. Okay, so for that we are supposed to check both the capacities. So keep in mind, whenever you design any member, I will repeat, whenever you design any member for, let's say, compression, then you are supposed to check it for tension as well. That's what we are doing over here. Lacing flat हमने compression member के लिए design, as a compression member design किया यहाँ पे. And the next instant we have checked what will be the tensile strength or tensile capacity of that same member. Okay? From that, since it has only a single bolt which will be involved, that we know, rather I know, that there will be only one bolt. If there are two or more bolts in any connection, I'm not just discussing about this, but whenever you come across two or more bolted connection, specifically the angle section, you are supposed to take care of the block shear failure as well. ठीक है? Block shear failure, I think I have shown you the complete video related to the block shear failure patterns. There are different modes of failure, and in those modes of failure you will come across this block shear failure pattern, especially for the angle sections. ठीक है? So over here, since we want, it is a flat plate. Okay, flat plate may experience block shear failure, but if the number of bolts are more, यहाँ पे मुझे मालूम है कि कोई ज़्यादा number of bolts नहीं है, but in case in your design, if you come across more than 2 bolts, you are supposed to verify the block shear failure capacity as well. Now let us discuss this. I think we have discussed all these things. Net section rupture and gross yielding, and it is safe. It comes out to be safe. I had also asked you people to conduct one test which will have thickness of 10 mm, क्योंकि आप लोगों के कैलकुलेशन में वो 10.00 समथिंग आया था, तो that you can do and you can verify whether it is safe or not in compression. If it is not safe in compression, then there is no point in checking in tension. If it comes out to be unsafe, revise it and then go ahead. Anyway, the next step is to design the connection. Connection in the sense, now we will see actually how many number of bolts are required. ये तो मेरा assumption था कि एक ही number of bolt रहेगा, and इसलिए ये मैंने, अगर आपके कैलकुलेशन में 2 या उससे ज़्यादा आते हैं, don't forget to check it for block shear failure. ठीक है? तो ये स्टेप आप पहले कर लो, कोई प्रॉब्लम नहीं है, सेफ आया, कोई इशू नहीं है. 2 या ज़्यादा आ रहे हैं bolts, keep it as it is. After this connection design, you check it for block shear. You can do that. अगर उसमें अनसेफ आता है, then you go for the revision. ठीक है? But this is not for your examination point of view. I am telling you as a practical aspect. एग्जाम में आप लोगों को सिर्फ यही लिखना है कि consider higher section or consider higher diameter of the bolt, whatever may be the case. Understood? So fine. So what we are doing, we are assuming 16 mm diameter bolt, and the grade and all, actually it is mentioned in your numerical, so it is 4.6. Now here I have written that the strength of the bolt is double shear. Why I must have written this? So for that you please refer this figure. ये figure में आप लोगों को क्या दिख रहा है? These two lacing flats, they are getting overlapped. So there are 2 flats. In addition to these 2 flats, there is this member. ये जो flange है, ये भी है. So there are total 3, you can say, plates which are getting connected at one joint. Over here, and therefore it is very evident that the bolt will experience double shear and bearing. Correct? So you identify the strength of the bolt in double shear. This is the formulation. Find out the value. कितना आता है value? देखो check करो आप लोग. You please verify. What should be FUB? 400. Gamma MB? 1.25. AN? Yes? Karo calculate. How to calculate AN value? 0.78 times the gross area of the bolt. AN is equal to 0.78 times pi d square by 4. D here would be 16. How much? 58.01, 57. Okay. ठीक है, 58. I must have considered that value to be 0.8. 0.8 times the gross area. तो उससे आएगा वो 58 point. कोई प्रॉब्लम नहीं. Even if you consider 0.7, it doesn't matter. Then you check it for bearing. Now listen carefully. Bearing, as I have told you, it should be. I mean, the capacity in bearing should be more than shearing. For that, in order to keep that value to be on the higher side, you can assume KB value to be 1. So therefore, I have said that assume KB to be 1. Calculation will become easier. और आप देखोगे कि strength of the bolt will be the least. From this strength of the bolt, calculate the what you can say number of bolts which are required. But before that, you are supposed to calculate force on the bolt from the lacing flat, because that bolt will be experiencing some sort of force, which I have written it as 2 times Vt by n cot theta. So in order to understand this concept, this figure has to be referred. देखो यहाँ पे क्या हो रहा है? At this point or at this bolt, this is the internal force which is coming from the lacing flat, which is in the form of, let's say, compression, and this is in the form of tension force. So you can see the vertical components of these two forces, they are acting at this point. बराबर है? और इसका horizontal component जो है वो nullify हो जाएगा. Correct? So therefore, this will be the only force in the form of vertical. Vt by n cot theta and Vt by n cot theta, that is nothing but 2 times Vt by n cot theta, that will be acting at that bolt. So this is the total amount of force which we need to consider in order to calculate the number of bolts which are required. So you will observe that for that very small force, 27 kilonewton compared to the complete 1000 kilonewton load which is coming onto that column, that is very small. So for that, force divided by the shearing stress and the bearing stresses. So shear strength and bearing, it comes out to be minimum of this 58.01, and therefore you will observe that that value is in point 0 point some value. You can round it up to 1. So here you can find only 1 bolt is required. It is sufficient enough to do the connection. Okay. So there is no need to go for the check of block shear. No need. Those 2 checks are sufficient. So you can swap this step. You can initially find out the number of bolts, and then you can go for the check. That you can do. उससे आपको confirmation मिलेगा कि नहीं, अगर 2 से ज़्यादा है तो आपको check करना पड़ेगा. So on. Is this okay? ठीक है? So here, what we have done, we have considered that 2 flats, they are getting overlapped. In case they are not overlapped, ऐसा भी रहता है, they are connected separately. In that case, what will be the value? What value do you expect, or how many number of bolts do you expect in that case? I am talking about this situation. for this situation? What do you think? How many number of bolts will be required for this case? Two number of bolts? I mean at one connection. For that, you identify what will be the force that will be transferred over here. And based on that force, then you evaluate the number of bolts which will be required. I hope such will be the situation and such will be the case. तो इसका vertical component, horizontal component, like this. And over here again. This is the situation will be same if I am not wrong. Okay. It will be same. So again, you will find that for this case also, the number of bolts which will be required, it will be one number. Okay. So this is how the lacing is to be designed for case one, where the the channels are facing back to back. Now let us discuss about when the channels are placed toe to toe, like in this condition. Okay, do you remember what did I tell you about this spacing condition? From where do we calculate this spacing if the channels are used? कहाँ से कहाँ तक spacing हम define किए? From which point to which point? Yes. Students who are online can even contribute. Yes. बताओ कहाँ से कहाँ तक रहेगा? Yes, wheel to wheel. Yes. So this is the situation. This will now be your S. ठीक है? पहले के सिचुएशन में क्या था? It was something of this sort. ठीक है? And for this, we have considered this to be S. Now over here, this will be the C1, and this will be the gauge. This will be the distance from here to here. This is G. And this will be C1. ठीक है? The connection will be something of this sort. Okay, this particular case. Right? What do they expect? What will be the changes in the equations? What will be the changes in the equations if I consider this equation, let's say A1. A1 का equation क्या था for this case? 2 times what it was? S plus G plus D. Cosec theta था कि cot theta? Cosec theta. Yes, how much it was? Cosec theta is what? Cot? Was cot. Now here, what will be the change? So, for this case, for this situation, I can say this is okay, this is true. And for this case, this now will be, A1 now will be 2 times A1 will be equal to 2 times S minus G minus G. That will be same. Except for this minus, because you can see we have considered from this point to this point, and if you observe that all these dimensions of G, they are inside compared to the overall S. Secondly, for the calculation of the effective length, again, instead of S plus D plus D, that will be S minus D minus D. That will be the only change, right? Rest, all the steps shall be same. So let us try to understand. When two channels are placed or connected toe to toe with single lacing system, same figure I have drawn. Okay. This one, this will be the CY value, this will be your G value, whatever I have marked, correct? And now, one more, yes, for calculating this D, D is what? See what we will be doing. We will be using the parallel axis theorem, and we will be identifying this, what you can say, distance, perpendicular distance, right? So in order to calculate this D, what will be the value? D will be equal to S by 2 minus C by. Correct? ये जो है इनका पोर्शन minus C1, that will give me D. Okay? So that will be the, again, one change, important change. And because of this important change, your S value will be different. So you can verify that. So again, in order to develop a build-up section, this formulation is important. That is, moment of inertia about both the axes should be same. What we are doing, we are enhancing the radius of gyration about the minor plane or minor axis. For that, we are equating both the moment of inertia values. And then you can equate it, substitute that value of D, S by 2 minus CY. CY is same because we are assuming the same ISMC 300 channel sections, right? For that, the CY value is 23.5. We have already discussed this. Everything is in mm. You please calculate this S value. Verify it. Verify the value. $276 point something. So some of you may even consider 277. Some of you may even go for this value. Okay, 278. I have increased it. Some even value I have considered. So no two designs can be same. Are you getting me? No two designs can be same because while rounding up, the values may differ. And this is true only when the exam will be conducted offline. Otherwise, all the designs are same. बराबर है? है? कितना रहा? बराबर है? ठीक है? Now you please do the rest of the design part. You please conduct the design and see. You can refer the earlier discussion and what difficulty you face. I am here to discuss. You please carry out the design, complete design for this. चलो. क्या? हाँ. चाहिए? देता हूँ ना? अभी रेफर करो फिलहाल मैं देता हूँ डोंट वरी अबाउट सो आई थिंक ये सब वैल्यूज आपने लिखे हैं क्या लिखे ये स्टेप यू कैन स्टार्ट विद दिस करो ये भी सेम रहेगा एवरीथिंग विल बी सेम द चेंज विल बी ओनली फ्रॉम हियर स्पेसिंग निकल गया यू स्टार्ट विद दिस करो चलो डिजाइन फॉर द सेकंड केस I will be uploading this PPT today itself. अच्छा, one more thing. See, ये जो lacing हमने provide किया है, as per your IS 800, it says it recommends that the lacing flats, whatever you are providing, that should be mirror image. That should not be alternate. Meaning of this is, if I am providing lacing on the front face to be like this, on the back face, it should be like this itself. Mirror image of that. It should not be like this. Okay. It should not be like this. Because again, if you provide it like this, then it will be a sort of mechanism. Again, load carrying or load transfer will take place, for which it is not recommended or not designed at all. Okay? So we are supposed to avoid such kind of alternate type of lacing patterns. It should be mirror image. Double lacing system that can be provided if the load is quite high. If it is more, जैसे अभी ये न्यूमेरिकल में कितना दिया है लोड 500 नहीं कितना दिया है लोड sorry 1080 so if it is more than 1500 kilonewton in that case double lacing system can be provided. Battens are not at all recommended. They are not recommended, but you will find everywhere battens are provided. even in your canteen area, because they are very easy to place. कौन उतना एंगल देखते बैठेगा 45 डिग्री का इंक्लिनेशन है, सीधा पैटर्न प्रोवाइड करा. ठीक है, चलो करो आप. Okay, one more thing, just information. What happens if you provide the lacing system along the length of the column? It may happen that some portion at the end of the column, it may be left as it is. I mean, there won't be one more, it won't be possible for us to provide or accommodate one more lacing flag because of the height constraint or the length constraint. In that case, at the end, usually at the end, such kind of system is provided. This is known as tie plate. Tie plate. इसका भी एक डिजाइन होता है, very simple design. I will provide you the steps related to the tie plate design. Okay, so you can also provide such type of system when it is not possible for us to accommodate the lace for the end. So usually you will find it at the end itself. Okay. Tie plate design. Okay. Something similar to the battens, because battens are also in that shape, flat. Okay. So be careful while solving. Instead of plus, s plus g, it will be minus everywhere. Pass the mic. Anyone who is interested in developing some program in any language which you know, which you are comfortable with, you can prepare one program and develop your own design, what you can say, program, small programs pertaining to different conditions. So how many of you are interested in doing this activity? One. Good. Which programming language do you know? MATLAB and Python you know? Great. Great. Why I am saying so? Because in the batch of 2020, 19, there was one student, third year में था, Kundan Moria. He attempted to develop one application, mobile based application जो रहते हैं, और उसने उसमें डिजाइन भी करने की कोशिश की. He tried to collaborate with some computer science students, but somehow he was not successful in that way, so that it can be commercialized and all. But he gave an attempt. I still have the application, his application. If anyone is interested, you can see. You can even contact. हाँ हाँ बिल्कुल. कौन है? Who is? ठीक है. So you people can get collaborated and you can come up with such type of good projects. These are, you can say, projects itself, because it will be a new thing. You can provide solution to the civil engineer students, those who are in the learning stage, your friends only, of other colleges and all. And you, after gaining more knowledge related to the behavior of the overall behavior of the structure, the boundary conditions can be known to you people. अभी क्या है? Isolated सब चल रहा है. Isolated column, isolated member. Exact boundary condition nobody knows. We are assuming everything. So slowly, once you get more knowledge related to the overall behavior, because why I'm saying behavior, you see, the structures are differentiated into two parts. One is sway and another is non-sway. Have you heard about these two terms? Sway frame, non-sway frame. तो sway frame का behavior कैसा होता है? there is a deflection at every stage. For non-sway it is rigid. तो अगर नॉन स्वे है कोई भी स्ट्रक्चर तो हम उसकी बाउंड्री कंडीशन फिक्स अज्यूम कर सकते हैं. Are you getting me what I am trying to say? If it is sway, then it is somewhere between fixed and hinge. It won't be fixed because it is getting deflected. There is some kind of translation. Got me? वो हमारी assumption है नॉन स्वे ऐसा कुछ होता ही नहीं. नॉन स्वे क्या होगा? If it is multi-storied, it is going to sway under horizontal force. ठीक है? So this is the understanding level which you will be gaining when you learn few more advanced topics. Once you get that, then you can modify your program, whatever programming language you consider. Some of you can even go for the Excel programming. That is also open. ठीक है? That thing you can do. एक प्रोजेक्ट ले लो आप लोग, कोई प्रॉब्लम नहीं. You conduct one project. You take any of the numerical or number of numericals if you want to, numerical examples if you want to consider. You can take, you can program, you can provide solution. ठीक है? Great. So you can continue with this, complete it. I don't think there was any kind of problem while solving this numerical. If there are any issues, we can discuss. Next, in the next class, we will discuss some other topic. Right? So compression member, although I have covered few numerical examples, but there is one more condition, that is 4 angles. If they are to be connected or they are to be built up, then what will be the change that you can study, that we will take up in the practical class. Okay? I will stop here.